Hello everyone. My name is Anshul, and today we are going to discuss on a very important topic from DBMS, which is going to be equivalence of functional dependencies. We're also going to take a look on certain numericals so that we can understand its better understanding for it. So first of all, let me introduce you to functional dependencies, like what is it and what is it used for. So basically, functional dependencies is a constraint between two sets of attributes in a relation. As you can see that suppose there's a two tuples which are x and y. If x attributes meets y, then you should must agree with y, which means if x tends to y, you have to agree for both y tends to x and x tends to y. It also helps in defining structure of relational database. Uh, as you can see here, the student name, in this, the roll number determines the student name. This is an example of it. So as we can see here, this line shows that two sets of functional dependencies, which are f and g, are equivalent if they imply each other. So f and g are only equivalent if they imply each other. That is what it's trying to say. And the second bullet point says that if f is equivalent to g, if only if f plus is equals to g plus, it means they generate the same attribute closure when f is equivalent to g. Equivalence is essential in simplifying and optimizing database design. It also reduces redundancy while maintaining consistency. So basically, consistency is very important for database management. That's why as much we can reduce the redundancy, it's better for us because it makes the deep management system more consistent. So basically, there are some rules for equivalence, which are also known as Armstrong axioms rule. We're going to take a look upon this one by one. So the first rule is of reflexivity. In this, as we can see, if y tends to x, then x tends to y. It shows the reflexive property of xy. When y is equal to x, then x must agree on y. Second rule is augmentation. In this, if x tends to y, then xz and yz for any z. So basically, it's trying to say that if x attribute tends to y, we must agree on the third generator attribute, which is z, for x and y both. Third is of transitivity. In this, we can see that if x tends to y and y tends to z, then x tends to z. There are also some other derived rules, which are first is union, second is decomposition, and third is pseudo-transitivity. So union, as we can see that if x tends to y and x tends to z, then x must agree for the attribute of y and z because x already tends to y and already tends to z. So x must agree for both y and z. This is what union tries to explain to us. Uh, Similarly, in decomposition, if x tends to yz, then x must agree on y and x must agree on z. This is for decomposition. And lastly, pseudo-transitivity. In here, if x tends to y and yz tends to w, then xz must agree on w because w is attribute of yz and y is attribute of x. So we must agree on xz attribute tending towards w. So in next case, we are going to discuss on Why functional dependency equivalence matters. So first point, it ensures minimal and complete representation of dependencies. Complete representation of dependency is very important. So it ensures that it aids in identifying candidate keys and designing normalized schemas. Basically, it's used for identifying candidate keys that helps in designing normalized schemas and helps prevent anomalies and ensure data consistency. So consistency is again very important for functional dependency. Uh, it can be done by preventing as much as anomalies we can prevent. So yeah, it helps in preventing anomalies. For that more consistency we can ensure for the system. Used in decomposition of relation without data loss. We can decompose it all the relations without losing any data. It ensures that and it helps in that. That's why functional dependencies are very important. Now we are going to look a numerical example for it. Here we can see that we have given f function whose attributes are a tends to b and b tends to c. Our task is to find closure of A and determine if A tends to C is implied. We have to check whether A tends to C is implied or not. So for solution, we can see that first step would be we have to check given. What we have to check that here we can say that A tends to B, which is already given, and B tends to C, which is already given. So by applying transitivity rule, like we have seen in earlier rules we have discussed, uh, which is the third rule of equivalency, which is transitivity. Here, we can ensure that if A tends to B and B tends to C, so automatically A tends to B. We have to must agree on A tends to C because C is a part of B and B is a part of A. So in the conclusion, F implies A tends to C, hence it can be added to F plus. We can generate another attribute by using this transitivity property rule. Another example, here we can see that we have given A tends to BC and B tends to D. And in another function G, where A tends to BC. So the question is F equivalent to G? So we have, here's the solution below. Uh, it, it describes as given A tends to BC, given in both. B is a part of BC and B tends to D is in F. In F function, B tends to D and B is a part of BC also. So A automatically tends to D can be derived. If A tends to D is not derived from the function G, then F not equivalent to G. So here we can see that in F plus, G is not concurrent to F plus, hence F and G are not equivalent unless B tends to D is also derivable from G. So here we can see that in the conclusion, as we can see that in here G, where F plus is not concurrent to G and F and G are not equivalent to each other, unless B tends to D is derivable. Unless this part is derivable, we cannot say that F is equivalent to G. So in the conclusion, we can, as of now, we can say that F is not equivalent to G because B tends to D is not derivable. F and G are different functions. So lastly, we have to discuss about these topics like what are the some conclusions of functional dependencies. So we should go through some checklist point, which are functional dependencies equivalence helps simplifying complex functional dependency sets. It helps in simplifying complex FD. So there are some of complex functional dependencies. So this equivalence help in simplifying them. And the rules we have discussed before, which are also known as Armstrong axioms rules. These rules are essential for checking and proving equivalence. There are transitivity and etc. Union and decomposition and many more. These all rules helps in checking and proving the equivalence of functional dependencies. Third point says that numerical problems strengthen understanding of functional dependencies, equivalent implications. And lastly, functional dependencies equivalence plays a vital role in database normalization and design integrity. So when we do database normalization, like we are removing anomalies, insertion, updation, deletion by dividing tables and reducing the redundancy, this functional dependency equivalence plays a vital role because we use rules and equivalence methods for simplifying the complex functional dependencies. This all helps in normalization, which is a very important part of RDBMS as well as regular databases. Now, we are going to see how to check the FD equivalence step by step. FD, we all know functional dependency equivalence. We are here to check that how can we check that it is an equivalence functional dependency or not. So there are some certain steps for it. First one is compute closure of left-hand side of FDs in F and G. When we have give two functions like F and G, we have to compute its complete closures on the left-hand side. Secondary, ensure each FD in F is implied by G. So where we can see that if a function have x tends to y and g have y tends to z. So y should imply that we must agree on x tends to y because y is a part of x. That's what it's trying to say. Thirdly, ensures each FD in G is implied by F, which is exactly the similar that I have explained in the second bullet point. It's the vice versa. Whether we have simplified F by G or G by F, we have to make sure for both F and G functions. Also, if F plus generator equals to G plus generator, then F and G are equivalent. If both the functions have some closure, then both the functions are equivalent and concurrent to each other. For all this, we have to use Armstrong axioms for stepwise verification, like we have discussed in the previous slide. Those rules helps in simplifying the FDs and checking the equivalence of FDs. Now we can see what are some real life applications of functional dependencies. So some real life applications, here are some points, we can go through it. FD used during schema optimization in real database. So when we have real database, when we have real databases, it always have some schema. So this application of FD helps in optimization of those schema in real databases. Also, it helps in ensuring that the schema is not overcomplicated, because if the schema is overcomplicated, we will not be able to understand the database. Thirdly, helps identifying redundant FDs and remove them. It also helps in identifying the redundancy of functional dependency and reduce them, or we can say the remove them. Like anomalies, we can say that as much anomalies we can remove, the more the function will be consistent. And lastly, avoids unnecessary joins and improves query performance. When we apply a query, or I can say when we run a query, we have to make sure that there's no unnecessary joins or acquiring positions and storage for it, which makes the query complex process. So we have to make it simplify query. So this functional dependence helps in avoiding those unnecessary joins. And here are some practice problem for it. We can see that given f is equal to a tends to b and b tends to c and a tends to d. And the question is whether a tends to c or a tends to d is equivalent to f. So we can solve this by applying axioms rule and check for the functional dependencies. Also, here are some checklist point which simplifies for the given problem solution. Try finding a plus for both. We have to try finding the closure for a for both, like we have f is equal to a tends to b and b tends to c and a tends to d. So we have to find, first of all, we have to try finding the left-hand side closure of a, which is b. Also, as I said, we have to use Armstrong axioms rules to derive the results. There are transitivity, union in decomposition, and pseudo-transitivity. Those rules we can apply here for solution for it, and discuss the steps used in proving equivalence. So we have discussed the steps in previous slide for proving the equivalence, whether it is equivalent, concurrent, or not. Like uh, seeing the both side functions of f and ga. Here we can say f is the only function and it has three attributes which are correlated to each other. So all those steps will help us to solve this question. We'll be trying this in on regular basis, and this kind of question will come in DBMS most probably. So here's the all the detailed requirements or description for functional dependencies. We can go through, and this is what helps in database management and relational database management, etc. Thank you.